My name is Fernando, and in this video I want to show you the essential knowledge about the JDBC API that can improve your backend communication with relational databases. I will also talk about how this API can be integrated with the framework of your choice and what are the things that you should avoid doing in the enterprise systems. So let's start. Talking briefly about the history of the JDBC API, it started in 97 when it was included in the first versions of the JDK by Sun Microsystems. And since the version 3.1, the API specification is being maintained under JCP. If you don't know what JCP is, it's basically the Java community process in which large companies in the enterprise and open source world can propose and vote for changes to the spec through JSRs. The last approved JSR was the 221 with one version and three maintenance releases that was included in the JDK by Oracle. So moving on, what is the state of the JDBC API today? Well, the JDBC API is a vendor agnostic API, which means that the database vendors must implement the code according to the spec as well. It also provides a good foundation for building high-level APIs on top of it, and with a very great performance. And keep in mind that despite of the data persistence solution you are using right now, you will need a connection pool to control and scale up your database resources. So as you can see here, on one side we have one or more web servers running Java, but in the middle, in front of our database, we have a connection pool with 20 connections on there, just as an example. So each web server node can only use this number of connections. And then some web server will take one of these pooled connections in order to do something with that. And later on, after the connection be used, the connection pool will just reset the state of this connection before it returns to the pool as an available connection again. So this is basically how a connection pool works, and the implementation that will be used here is Agro, an implementation of Red Hat. It has been used since the JBoss AS, and now it was ported as a Quarkus extension too. It's also good to mention that JDBC comes with some trade-offs as everything in life. So for example, you can have a lot of duplicated code, even to perform basic operations on that. And this duplicated code can end up being mixed with transaction management components, which is not so good because in general, the demarcation of these transaction boundaries is tied to your business logic layer. It is also a bit more risk API because there are some things that developers could get wrong, like for example, forgetting to close database resources. And also the developer may accidentally change in the state of some connection and forgetting to reset this state before reusing the connection again. So you may end up with a stale connection problem here. So that's why we don't trust anything. We always should verify. And in order to verify the possible solutions to those problems, we will need a test environment first. In this proof of concept, I will be using a Postgres database running on Docker with test containers. And for the project, I will be using Quarkus. That is the easiest way to start a new enterprise project today. So get you some coffee and let's dive into the code. So first of all, you need to open up the Quarkus.io website and go here on Start Coding. I will be using the latest version of Quarkus as this is just only a demo, and also the latest stable version of the JDK. For the build tool, I will pick Maven just to keep it simple, and of course we need to set the group ID here, and also the artifact ID of our project. Now we need to select some extensions, so first will be the REST Easy, then of course the Postgres JDBC driver, and also the Agro database connection pool, which is included in Hibernate, by the way, but in our case, we need to select it separately. Okay, so just go here on Generator app and download the zip file. Now it's worth mentioning that you will need Docker running on your machine. Okay, so now I can unzip the project. And as you can see, it's a basic Maven project, nothing special here. So I will just run mvn compile Quarkus dev to run Quarkus on developer mode. And it will start to download all the required dependencies. In my case, it was very fast as I already had these dependencies on my machine. And maybe you didn't notice, but Quarkus already started a development environment for me. And this is possible mainly because Quarkus ships with a feature called Dev Services, which will kick off all the Docker containers automatically. But it only does that if we don't provide any configurations at all in our application.properties file. And of course, if you provide some config here, it is also an option. But by using this dev services approach, we can focus on only the things that matter to us, so really a time saver feature. And just to prove that, here is the Postgres container and also the test containers. And one more cool thing that Quarkus provides is the development panel. So let me show you. It's under localhost 8080, which is a nice dev UI that can be very convenient for us as developers too. Moving on to the code, the only configuration that I'll set for now is some JDBC metrics. You'll see the reason for that in a second. Okay, and what I want to do now is to create a class here. And this class, it's going to basically be my execution entry point to demonstrate to you how the JDBC API works. Okay, so this will listen for the Quarkus startup event. And as this is an application scoped bin, we have the post construct method. And now I can inject the data source here that points to our database connection pool. And now I can call get connection. And of course, this needs to be surrounded inside a try-catch block to catch the SQL exceptions. Okay. And just to keep it simple, I will do some dummy example here, like getting the current timestamp from the database. Okay, very, very simple. And this will give me a statement here. So with this statement, I can call the execute query that will retrieve a result set that basically points to my database cursor. And with the cursor, I can call .next to move the cursor to the next row. But of course, in our case, we only have one row. Okay, so to consume that, I will call result set.get string. And you can pass here a column index starting at 1, not at 0, okay, always at 1. Or there's another ways, for example, getting the object. So I will convert that to a local datetime class here. And just to demonstrate to you, I will put some login here and call log.info. And don't forget to close the connection. This is very important. But keep in mind that this is not physically closing it. As I said before, the connection will basically just return to the pool. Okay, so now let's see the result by restarting Quarkus. In order to do that, you can press S to trigger a forced restart. Okay, so now as you can see, Quarkus detected my newly created class and also the changes that I made to application.properties file. It gives you really fast feedback. I could keep restarting it and still blazing fast. Okay, and if you pay attention, we have a warning here telling us that the JDBC resources leaked one result set and one statement as well. So this is a very, very dangerous leak, as you may know, because the database has very limited resources. And to address these undesirable leaks, to get away from them, we can close the result set and also the statement as well. So by doing that and restarting Quarkus, as you can see, the warnings disappeared. But we are not done yet, because what if our code throws some exception right before we close the resources? We'll still have to deal with resource leaking, right? In order to fix that, I will remove this code and I will add a try finally block here at the end of our method, and I will check if the connection is not null. Then I call connection.close. And of course, I need to surround that inside the try-catch too. And I will do the same thing for the result set and for the statement as well. Now if I put some breakpoints here and restart Quarkus, you'll see that even if some exception was thrown, our resources are being closed, as the finally block always will execute. But the problem now is that the code is a bit messy, but of course it's more secure than it was before. So what is the next step to improve the code that I showed before? As you might know, since Java 7 we have this nice try with resources feature. You can learn that through this Java tutorials documentation. But what you need to know about that actually is that every statement inside that try with resources block must implement the auto-closable interface. So if you go there on the Java docs link, we have here the JDBC related objects such as connections, statements. We also have other objects that deal with I/O operations such as strings, and even file managers are listed here. So it's a very useful and practical feature. Okay, so let's implement that in our code. I will just surround the result set with try with resources block. I will do the same for the prepare statement and the connection as well. Thus, I can remove these lines here, and now we don't need to explicitly close the resources anymore, as Java already does that for us. However, there are more advanced use cases for the JDBC API, as you may expect. So what if we need to deal with transactions, for example? In that case, we will need to demarcate the transaction boundaries by changing the connection commit property to false, as the default is true. And then we call connection.commit if the operation was successful. In case of an exception, we need to roll back the transaction. And worse than that, we must not forget to reset the state of the connection before calling close. So do you realize the what if questions? I think that we as developers need to ask ourselves these kind of questions every time. Because what if I spread the code that I showed before on the entire code base? The code will probably get unmaintainable and even more complex over time. That's why we won't be using just plain JDBC. We need something more. And what we need actually is JDA. JDA is the Jakarta Transaction API, and is responsible for dealing with the transaction boundaries for us. So it will execute all the procedure or nothing. So it means that if some exception was thrown in the meanwhile, this transactional will be rolled back. So otherwise, it will commit the transaction. It's also an API very well integrated with CDI and even with AGBs. And JDA also allows you to span a transaction across multiple data sources using XA transactions, which uses a two-phase commit protocol, by the way. And the implementation that will be used here is the Narayana JDA from Red Hat. And you may argue, why is that so important? So as you may know, data corruption can have serious consequences on the enterprise, implying in system reconciliation costs and even damage to customer relationships. And JDA is a very self-explanatory API. It comes with the transaction annotation that can be placed at the class level, but traditionally it's more used on top of our service methods. So far, we have here 6 propagation strategies. The most used one is required, which is the default, by the way, and means that if there's a transaction going on, it will be just reused. Otherwise, the JDA container must start a new transaction. We also have the require new, which is very similar, except that it will always start a new transaction. And in case that it already started a transactional context, this context must be suspended until the new transaction completes. The mandatory, it will basically just throw an exception if the method was called outside the transactional context. And we have the support, which is the opposite of mandatory, so it allows any transactions, but of course is not mandatory. And the last 2 strategies here are not so common, I would say, but you could look at that later. So going back to our demo, now I can put the transaction annotation here, and our code is more clear, and we know that the JDA container will roll back this transaction if some runtime exception is thrown. And you can see more detailed information in your console by pressing J to switch to the debug log level and then restart Quarkus. And as you can see, we have the auto commit property being set before and after the execution of our method. So now we are not hard coding the transaction management anymore, which is very great. But unfortunately, we still have very verbose and complex code, and we need to come up with a solution for that. So what is the solution? And the idea is quite simple. We will need to create a custom JDBC wrapper on top of the JDBC API, and it will be very well suited for our needs, as we can change this internal code whenever we need. So hands on the code again. So I prepared here an initial code just to save some time on the implementation later. I will put all the JDBC related tests in this class, which is a Quarkus JUnit test. So here I have the book record and 2 constants representing 2 different books with some common properties on there, and also a SQL constant to insert the book later. And these 2 methods here, they are part of the JUnit test cycle, so it will create and drop my book table for each JUnit test invocation. I also have the book statement that receives the book record on the constructor and implements the prepare statement handler. And this is going to be used to set the incoming parameters of the book before sending, for example, an insert or update statement to the database. Okay, so if you inspect this prepare statement handler, it's basically a functional interface, and if you are not familiar with functional programming, it will work. Take a look on that later. So here on the method signature, we are receiving the prepare statement. But note that this is not the original prepare statement, but a custom one. If you inspect that, you will see that it provides some additional methods like set UID, set local date and time, and so on and so forth. So the implementation of this handler is a wrapper class that also implements the auto-closable interface. So it can be declared inside the try with resources later. And here on the constructors, I'm receiving the connection and also the SQL object. This statement will always be prepared internally, and this reference will be assigned to the delegate field, which is now the original prepared statement implementation. Okay, and then we get the handler from the encapsulated SQL object here, and pass this class as a reference in order to be able to execute the callback of our functional interface. So this is exactly how a wrapper class works. And know that our SQL object here is just encapsulating a string builder of the statement. And this class also performs some basic things like logging whenever the get method is called. Okay. And this class also have a subclass, which I call it query. And what this class does, it will basically append the limit and the offset clauses at the end of our query. So if you go back to our prepared statement wrapper, you'll see that if some statement was prepared using a query class to read some data, for example, we check if the instance type matches, and if so, we check if there is a limit and the offset values that must be applied. And to do that, I'm using a Java 16 pattern matching feature here. That is just a typecasting shortcut, but it could be a yodcast expression as well. It will works. And the last thing about the statement wrapper class is that each setter method here is pre-incrementing this column index number. So we don't need to pass the column index anymore to set the incoming parameters of our prepared statement. So I put all the code on this GitHub repo, as you can see, and I also split it into some different branches to keep organized. But for this video, I'll be using this last one branch. So going back to our code now, we need to execute these two statements here before skipping to our tests. And in order to do that, I created this Postgres application scoped bin class. And basically this class will perform all the database interactions for us. So here I'm exposing only one method for now that accepts any kind of transactions. And this method will execute the SQL statement without retrieving the affected rows. Okay. And then if some exception was thrown, we must execute this callback. I'm using method reference here, but you can replace that with a lambda if you want to, okay? And with the exception, I will delegate that to my custom Postgres specific handler that is under the exception handler package. It will decode the kind of problem we have. So for example, we store the Postgres SQL state here. So if you take a look on the Xenon, you'll see that it has a lot of options here and also some utility method. And by doing that, I can now handle the exception. So by checking the node availability, and then it will basically check if we are facing some kind of timeout problem. If so, we throw an exception to say that our database node is unavailable for now. And I did the same thing here for some kind of out of memory or connection problem. Okay. So, and of course, you can map that to a JAX-RS exception mapper. And for example, you can retrieve some HTTP 503 to our client, meaning that your service is not available at the moment. Is also an option. So if you go back to our Postgres class, we have the possibility to execute any statement by calling this method here. So we should call that in our test. So I'll inject the Postgres bin here. And now we can call that. And I do the same thing here. And now if we put some breakpoint, and also I will create an empty test to verify. And if we debug that, you'll see that our table is created before our test, and after that it drops the table. So everything works. Now we need to implement our first JUnit test that will insert a row in the database, returning the generated key. However, how can we start a new transaction context here, but without relying only on the transaction annotation? That's why I added a couple of overloaded methods here, as you can see. So we can invoke some of them, providing a runnable or even a supplier, for example. In that case, the Java compiler will return the infer type according to our context. And if you don't have ever used this Java feature, it will be good to take a look at the documentation later. So I'll call the postqueries.with transaction here, passing our runnable. And of course, can replace that to a lambda. And now in order to insert the book record in the database, I created this method here that will pass our UID column name to the prepare statement. And this is basically just a kind of JDBC hint to say that we want to retrieve one or more generated keys. So it is the same as doing, for example, insert returning UID. But traditionally it's more used something like return asterisk. And if you want to do that, so just replace that to a flag here, JDBC flag. But this approach here is not very efficient because it will retrieve all the generated columns for you, and it's probably not a desired behavior, okay? So I will stick with the column names, and let's go back to our test to implement the second step. So I'll call postqueries.insert returning UID. And of course, we need to pass our SQL statement here, and also the book statement handler. And with the UID, we just need to assert that it's not null. And to test that, just go on the Quarkus command line and press R. And as you can see, this way of running the test is way faster than using IntelliJ, for example. So just to prove that, I will assign a null value here to the UID. And now the test should fail. And if I fix that, now the test should pass, okay? So I can rerun the test over and over again and without losing the fast feedback, which of course is very important. So to avoid repeating, I created some common features here on our JDBC wrapper. For example, this update method that can be used to execute any kind of DML operation, such as a simple insert, an update, a delete, and so on. And for the update returning, I created a separated method for that as well. And of course, I also implemented the DQL operations, for example, to read one row from the database, or even a collection of rows, as you can see here on this other select method. And basically, I'm looping throughout the rows and of the cursor and then mapping that to array list. And if there's no row to be returning, I basically returns a empty list. And if you go back to our select first method, you'll see that I'm adding this limit one clause at the end of our statement and then returning an optional. Okay, so remember, it's always good to return an optional instead of returning null. And to map the rows to something else, I'm using this row mapper here, which is a functional interface that consumes the row. And the implementation of that, of course, is our row set, which is also an autoclosable resource, as you can see here. And actually, this is just a wrapper for the result set. And to execute any query now, we need to provide a row mapper for that as well, which can be a class like I did here, or it could also be an anonymous class or even a lambda if you want. And I also moved the utility code away from our test class. That's why I added this book and book sample classes here. And besides that refactoring, I also added a couple of test scenarios here as well. So all the tests passed, as you can see. Going back to our first test here, you'll see that I also changed some things here to ensure that this is working properly. So I added this SQL query after performing our insert, and basically this SQL query is filtering the book by the UID, and to set the UID incoming parameters here, I'm encapsulating that inside this callback inside a constructor, but it's the same thing as doing this, for example. Okay. And if you pay attention, you'll see that also I changed our transaction boundaries to use this Quarkus specific annotation instead of using our functional methods. And basically what this annotation does, it will roll back the generate transaction after the execution of our test. So now the last scenario that I want to show you will be an insert with a fallback strategy. And basically this should retrieve the conflicted fields if some unique constraint was violated when we try to insert a new row in the database. Now, before we code this more complex example, it's good to mention that this approach here that executes a lot of reads before doing the insert, it's very common, it's very widely used, it's not wrong, but take as example the sudden invalidations in your code that just checks if some data exists or not. So it seems pretty defensive, and most of the time your validation will just pass and the record will be inserted in the database. So, and if you think about that, we actually don't need to perform these readings eagerly. We can do that in a lazy way as well. So the lazy approach is going to be a fallback operation that just tries to insert, and if the insert statement was successful, it will just return back. Otherwise, it will check the reason of the failure. So let's suppose that the failure was a unique constraint violation. So in your database table, you have some fields with the unique constraint. You can return back this data to your user. So only the piece of data that has conflicted, because your application can detect that as well. So finally, it will end up with just one successful write. Otherwise, it's going to be a one write attempt that will be rolled back, and of course plus one read. So it's better than executing n plus one reads and just one write at the end. So the first thing that I did here is insert the sample book, returning the UID. Then I select the title of this inserted book, and now I just provide the fallback query. So whenever the insert operation fails, this callback will get into action. And this unique violation query actually extends the fallback query class that just encapsulates the SQL and the row mapper object. So the only thing that it should do basically is retrieve a hash map with the conflicted fields, right? And in order to create a hash map, I selecting the title of the book, which is a unique field. Then I call this map method that will basically just extract the object of each column returned by my query. But note that you shouldn't be doing this metadata mapping in production. Rather than, it is expected that you create your custom row mappers, but since this is just a test, it's okay to do it this way. And now I just assert that already exists exception was thrown. And actually, this exception is being thrown by this custom exception handler that inherits the behavior of this Postgres super exception handler here. And then it just checks if the state, the SQL state is equal to unique violation. If so, then it throws the exception. Otherwise, it delegates the execution flow to the superclass, okay? And finally, the last feature that we should implement is the custom insert, and this custom insert will forward the fallback if something goes wrong. So let's implement that. Just let me paste the code here, and actually the first argument could be null, okay? And this method will start a new JDA transaction in case that there's a fallback to be executed. And of course, if there's some transaction going on, it will be suspended until the new transaction completes. As the propagation strategy defined here is requires new, okay? And then it will dispatch the fallback query when the supplier is called. And if there wasn't any fallback query defined here, the supplier will then just return an empty hash map. Okay, so we need to provide these additional methods to achieve this fallback behavior in our insert. So I will just duplicate this method here, and it will receive the unique violation query that of course could be null too. And I will pass the violation query as an argument to our private internal method here. And I will refactor this previous method to call insert returning ID, passing the SQL and null as an argument. And I will do the same thing for this update method as well. So this exception consumer will be something like this. Of course, we need to pass the violation query too. And then let's complete our JUnit test here. So I'll call the Postgres insert. Okay, we can call the insert returning ID, but I will do something different. I will call Postgres.update because it is also an option too. Okay, and I will pass the SQL here and the violation query that we defined before. Okay, so let's run the test to see the result. So it will it will assert that our hash map that stores the construct violations has exactly one key value entry with the conflicted information, which is our book title. And as you can see, it worked as expected. And one more thing that you might want to have is this nice ID color highlight feature on your SQL statements. And you can configure that as well. So just go on settings, language injections, and here you can add your class and then just select in which places of your code you want these highlights to be applied, okay? So I think that I covered the most important parts of the JDBC API, as well as the things that you should know for now. And to not start a battle here, it's up to you. Do you wish for more control of your database? Whether because it's your DBA recommendation or not, go with the JDBC wrapper. Or maybe do you want to just be more productive? If so, go ahead with Hibernate, no problem. And to avoid any misconceptions, one doesn't eliminate the other, so you can combine both of them actually, or even get the plain JDBC access from Hibernate's internal API. So thanks a lot for watching. I hope you enjoyed it, and I will be waiting for you in the next video where I will show some performance tips that you can apply in our API to improve it even more. So don't forget to take a look in the links at the description below, and see you on the next video.